All right, distance learners. So first of all, there's no test tomorrow. I know I said I was going to try to fit one in before break, but it's not going to happen. It'll come probably the Tuesday after break. We will finish the chapter this week, so they're getting all their poop in a group while I'm talking to you. We are going to finish the last two examples, which have a direct tie into some of the FRQs, so we're going to go look at a couple of those. There's an extra credit option here as well. So no new homework today. Your job is to finish 6A, but if you want to try another FRQ on your own that's similar, I linked it over here in the resources. You can just turn it in with 6A for extra credit. So we're going to start because these take a while. So let me hop on to and I've got a lot running here, so I hope I don't crash. I've got my screencast, I've got Desmos, I've got Smart Notebook. I'm kind of hoping it doesn't max out. But on example 10, it says, we can integrate or differentiate a power series to obtain a new series. When you do that, when you do the integral or the derivative, the radius of convergence stays the same. So r, if it was equal to 1 and you do a derivative or an integral and come up with a new series, it will also have a radius of 1. But if we had maybe a IOC of -1 to 1, maybe we are centered at 0, the endpoints can shift. So where they once diverged, if you integrate, they might converge. So you have to retest. You're usually, if not always, prompted with when you're supposed to take a derivative or integral. You wouldn't just think of it on your own. So on this first one, I'm prompting you to integrate to do this problem. So my goal is to figure out a power series centered at 0 for this function. By the way, from the notes for yesterday, anyone want to tell me what the radius of convergence is? Just cause? 1. Because there's an asymptote at 1, so we hit a divergence at 1, and we're centered at 0. So I'm actually going to have a -1 to 1 IOC just because I conceptually understand it. Unfortunately, that doesn't cut it for an FRQ. But it kind of, if you really get it, I kind of know that. I discussed that in the notes, didn't I? Okay, good, because those are notes from a couple years ago. So, anyway, so it says hint. So let's go follow the hint. Whenever you're given a hint like this, or like on one of the FRQs, it's going to say the derivative of arctan is, you're going to write that down. So it says hint, what is this? So we're going to go back to Calc AB and actually figure out what this is, right? We're going to integrate it. What rule will we use? This is u sub, right? So it's u to the -2nd, technically, with a negative correction out front of it, right? So really in there, I'm just going to write it down. I have u to the -2, but it would be a negative du from the derivative of the guts. All right. So when I write this out, my antiderivative of u to the -2nd is -1 over u to the -1 over -1, but I had the negative correction. So really, I just have 1 over u. I'm going to write that down. 1 over u. If I take this guy's derivative, I better get this guy, right? So the question is, did you hear what I just said? That was really important. Watch. What's the antiderivative of 2x? Go ahead, tell me. X squared plus c, correct? The derivative of this is that. So the derivative of what I just came up with has to equal 1 over 1 minus x squared. So when I do I just want you to follow the flow of this. When I do the derivative of my 1 over 1 minus x, I should get what I'm looking for. 1 over, I'm going to let you digest that for just a second. So I wrote it kind of fast. I'll scroll, and I'll let you kind of digest what I just basically said. The derivative of this has to equal that. This is what I'm looking for. This is super, super nice because this is geometric. And it's the easiest geometric. It's in the form a over 1 minus r, right? What's the a? 1. What's the r? X. So I'll really just be taking the derivative of 1, right, plus what? I'm going to expand it. 1 plus what? X plus what? X squared. Let's take it out. It didn't say how far. I'm going to go out to maybe x to the 4th plus blah, 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 x to the n. N is starting at 0. I like to write that under there. Plus dot, dot, dot. That will equal. So I'm just saying the derivative of my antiderivative has to equal what I want. And my antiderivative has a really nice geometric expansion. So you're nodding. Awesome. I love it when we nod. So let's go take the derivative of that, because that'll give us 1 over 1 minus x squared on a certain interval of convergence. It's weird that it's... Do you see that? It won't write over there. But there's a fraction bar. All right? So when I take the derivative, the 1 will go to 0, and I'll get 1. And then I'll get 2x. And then I'll get 3x squared. And then I think I'll go out to 4x cubed. And then if it just said the first four non-zero terms and the general term, it really doesn't say that. It just says find a power series. So I'm going to take it all the way out. N, x to the n minus 1, dot, dot, dot. That's actually equal to what I want. Am I going too fast, Lucy, or am I good? So let's write this with some summation notation just to wrap it on up. By the way, when you're doing your summation notation, you can see right here, I can do n x to the n minus 1, right? Be careful with your starts on these. So what do you want to start with for your n? 1. Why 1? Because sometimes it's 0. Because if I have a 0, right, won't it wipe it all out and I won't start at 1? So I want to go from 1 to infinity, n x to the n minus 1. That is a power series for this guy. The question becomes, and I don't know if it asks for interval of convergence or radius of convergence. What did it ask for? Well, the radius is easy from the geometric because that was our common ratio, has to be less than 1, right? So I don't really need to go do my ratio test, but that then means I'm from -1 to 1. But what did I say? Although the radius stays the same, what did I say could happen with the interval? You might gain or lose an endpoint. And for the geometric, I could really only gain 1. So you just need to run a little test on this guy, and usually it's super quick. If I put in a 1 for x, right, I would be doing, so if you let x equal 1, what's 1 to any power? 1. This is just the sum of n. So it'd be 1 plus 2 plus 3 plus 4. What does that do? Diverge or converge? Diverges. So 1's a failure. If I put in a -1 for x, it's just going to add an alternator in there, but it'll fail the alternating series test because its limit doesn't go to 0, correct? So I really did, on the next one I do though, we gain an endpoint, but this one it's so obvious that we diverge both ways. So really what I know, and I'm going to go hop on Desmos, is I'm going to go graph these. And what you're going to see, because you don't know what the graph of this one looks like, I'm assuming, right? Agreed? I think I'll graph, I think I have it up to, let's do, here, I'm going to, just so you can see it, I'm just doing these two, I just want to do them really slow. So in all my zillions of windows, let me find my Desmos, and I'm going to start writing that out. All right, so there's the original graph of f of x equals 1 over 1 minus x. Wasn't it quantitatively squared, or was it 1 minus x squared? Yeah, I was going to say, I think I typed it in wrong. Thank you. So let's do to the second. Why didn't it graph anything? Yes, ma'am. Let me try it one more time. 1 divided by parentheses 1 minus x, close it, to the second. There it is. All right? Now, mine that we just made, go ahead and what was it again? It was 1 plus 2x. Notice it, see the agreement at the center? Always agree. That's going to help us find Carl, by the way, because we always know a point. We always know that they agree in the center. 0, 1's on both. All right. Go ahead, read the next one for me. What was it? 3x to the second. See, now I'm fitting it a little better. from negative 1 to 1, right? And then let's take it a little up farther as 4x cubed, right? Plus 4x to the third. Well, now it's hugging it pretty nice from negative 1 to 1. I'm going to go one more, though. What would the next one be? 5x to the fourth. All right. So from negative 1 to 1, but not including, is where they're a perfect fit. I like to graph them so you can see it. So from 1 to negative 1. Those look really good, right? How could I make it way better? Keep adding and adding and adding, and eventually it's a perfect fit. But what do you think we call the distance between these two? There's some error there. We're going to get really into the error tomorrow. But what is the error always less than or equal to? If it's alternating. Did this one alternate? That's tomorrow. Well, can we still bound it if it's not alternating? The answer is yes, and it's called Lagrange error bounds. If it was alternating, though, let's suppose it was, we always say that the error is less than or equal to the absolute value of our first unused term, our foot, right? But the notation for this error is what I want to talk about because it's coming up in 2 FRQs. The error is the distance between the purple and the green, correct? The green is the exact function. What's the purple? It's my approximation. Exactly. Sometimes that's called A for approximation. Sometimes they'll call it, did I go out to the 4th degree? The Taylor polynomial of 4th degree. But that means you're working with your error. The distance or the absolute value, they could be swapped. Do you get why? Like I could have the function second in the polynomial first. Just keep that in mind that that's asking you for error without actually saying the words error. It's the distance or the absolute value between or the gap between the two. All right, awesome. You guys are awesome. So I'm going to leave that decimals running because I want it for the next one. It'll go back and find my notes. There they are. All right, and we're done with that one. So the next example, number 11. Full screen. All right, I'm asking a lot of my computer here today, which is probably why it's not erasing that. All right, so this one says, find a power series that represents this. Now, you could always launch into Taylor's rule, right? But aren't those geometric ones super easy to generate? They're so easy, and their IOCs and their radiuses are like dead ringers. So if you can use a geometric, you want, I shouldn't have walked away from my board, sorry. Sorry if you can hear me, guys, I'm back. All right, anyway, there's so many at home, it's like I have to make sure my notes are rock solid. So when it says hint, what do you think I want you to do just based on the last one? I want you to integrate that. Yes. So let's integrate that. When I integrate 1 over 1 minus x dx, you should be able to do that in your head, right? Go ahead. What's its antiderivative, Luz? Negative. Oh, okay, now it's erasing. What? I'm just going to erase while you're talking to me, Lucy. Okay. What'd you say? Negative? I think I heard her mumble. What else, Miss Mumbles? Mm-hmm. Oh, hey, this is what I want, right? Don't forget carb. Almost. So what do you think I'm going to get rid of so I have exactly what I want? The negative. So I'm going to go, and again, you'll be given a hint if necessary. You won't need to think that, all right? It's just a hint for trying to trigger geometric. Because my natural log, the thing I want, is negative of 1 over 1 minus x dx. This guy right here is geometric, right? I just need to integrate it and take the opposite of it. So when I generate that, again, that's in that form a over 1 minus r. So it's nice and easy. What's the r? X. Yeah, so this is going to be 1. And then I keep multiplying by positive x. If that was a plus x in the bottom, what would I multiply by? Negative x. So watch that because there's sign issues, but let's go do that. All I love you guys this chapter. I think you know it's weird and it's difficult. You have to listen and you're rising to the challenge. Very few sleepers. Sometimes I get sleepers because this is, right? I love it, distance learners. I actually do. I think it's cool, but I can see why it's your first experience with incredibly abstract theoretical math. And it can be so different that some people are like, oh, it's weird. It is. It's cool, but it's weird. All right, so what was I doing? Oh, here I go. I'm going to have to plus dot, 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 x to the n over n. Not over n, just x to the n. All right, there it goes. So now what am I going to do? Anti-derivated. It's easy, right? I'll have a negative because of Lucy's fraction correction from our antiderivative. But now I integrate. The last one I took a derivative, so, right? So x plus what? X squared over 2. It's easy to generate. X cubed over 3. I'll go to x to the 4th over 4 plus what am I doing? X to the n over n plus blah, blah, blah. I lost the prompt. Okay, I'm working on the power series for it right now. All right, it's negative x to the n over n. And where is my count starting? 1. Okay, so sometimes it's 0, sometimes it's 1. Rarely is it anything else, but there it is. Generate the power series, and then what else did it say? Radius of convergence. True or false? I need to run the ratio test. For the radius of convergence. False, because it's geometric, right? The absolute value of that r has to be less. I forgot I was recording. Sorry. So and I don't have the headset on. Do you get why I don't want the headset on? Like, with the mask, with what? All right. So no, this is what I know. My radius is 1. You could run the ratio test on there. You'll get 1. Okay. But remember what I told you about the endpoints. When you do derivatives or integrals like this to sort of trick the problem or to avoid using Taylor's rule, which is actually can get kind of ugly with the chain rule and the quotient rule and all those derivatives, this was smooth. It's weird, but it's smooth. But I told you you might gain or lose an endpoint. I want you to digest that. Go plug in a 1 for x and a negative 1 for x and decide if I'm still wimpy or if I gain 1 or 2 points of convergence. Sometimes on the AP exam, it'll say, does f of 1 actually equal your power series at 1? They're actually asking you, wimpy or beefy, will it actually converge or not? What would the answer be for this one? Let's go try it. And again, you should know how to write it out because we've done it a bunch. When you replace x with a 1, does 1 over n converge or diverge? It is the divergent harmonic. I can't stand still over here. It's driving me nuts. It's the divergent harmonic. So I know I'm wimpy here. But and you might say, what about the constant out front, the negative? Remember, constants just don't affect that. How about if I put in a negative 1, Carl, for x? Then it's an alternating series, right? Alternating series have to decrease and have a limit that goes to 0, right? So I picked up an endpoint. So if part B of an FRQ that had this as its like bulk might say, is f of negative 1 actually equal to the series evaluated at negative 1? And what would you say? Yes. Is f of 1 equal to the series? No. Do you see how they get asked in a way that they won't say is it beefy or wimpy there, right? That's what that means, is it hits it. This means it's so close, but doesn't quite get it. How are we on those two? We good? We're going to go look at our first FRQ. This says similar to 2008 because you're actually going to be doing 2008 for test prep. So it got tweaked. Do you think it's calculator active or not? No. The Taylor's series question is always number 6. Sometimes it's all about Taylor polynomials and Maclaurin and IOCs, and sometimes it's all about those stuff we did the last chapter, like with the tests. What it means is whatever one it's not about is hit like crazy in the multiple choice. All right, so it will be on one of those. Let's go start with this one. First of all, there's my function. 1 over 1 plus x squared. It says write the first 4 non-zero terms. It's important. 4 non-zero, not fourth degree. And I need a general term, so that's going to be worth 2 points. Thank you for Maclaurin. You have to decide, Gus, do you want to generate this with Taylor's rule, f of 0 plus f prime of 0 x plus f double prime of 0 x squared, because that'll work. Or do you want to outsmart it? That's geometric. If you didn't recognize it, it won't affect part A. Like if you launched into Taylor's rule, but what would the effect of launching into Taylor's rule be ultimately, like on your test? Time sucker, you probably wouldn't finish. Like time's going to get called probably before you get to even C. All right, because doesn't that take a long time? All right, so let's go do part A like this. F of x equals, this is of the form a over 1 minus r. A is 1, and I always like to write everything out when I'm doing an actual FRQ, so it triggers me like to do it correctly. So Gunnar, when this starts at 1, what will I now keep multiplying by consistently? Negative x squared plus x to the 4th minus x to the 6th. There's my first 4 non-zero terms. My general term you can either do separately or you can just stick it in here with some ellipses or whatever. So I would have x to the 2n, n greater than or equal to 0. Now tell me why you wouldn't get that point, Harvey. I did one of the most common things. I forgot the alternator. Have you ever forgot the alternator? Yeah. We forget that alternator sometimes. So -1. It didn't say write it with sigma notation. It doesn't matter if you do, you don't get points taken off, but it just said the general term. So as long as you tell me where to start, I'm good. So -1 to the n, I always check my general term when there's, so I'm going to check it. Put in a 0, get a 1. Put in a 1, Gunnar, and I get minus x squared. It's good. I'm rock solid on part A. I feel really good about it. Was there anything difficult about that? No. Okay, not if you understand. Like we usually score pretty high on these, but they're weird. All right, letter B. Does the series found in part A, this guy, when evaluated at 1, actually equal f of 1? I want you to see if you understand what that's asking you. Does the series, what's a better wording for that would make more sense to you, but that's not how it was worded. Does it converge at 1? Is it beefy at 1, right? What do you think the answer to that is? No, but that's a 50-50 guess. So, but it is no. Now, there's a couple ways you could say why not. Because who said no over on this side? So why not?
Because it doesn't really, it just alternates between 2 and 1.
So he's going to actually go over here and say, well, at 1, I've got an alternating, oscillating, divergent, that would work.
Yeah.
Totally. He's actually going to his rule of sequence, putting a 1 in for x and saying -1 to the n 1 is not converging. You could say it's also oscillating, or you could say nth term test for divergence. That's fine. Anyone else got some? I don't know that I would have chose that, but Gunnar, you get full points. What's another reason for sure why 1 doesn't get included? Remember, I didn't take any derivatives or integrals. What's the common ratio? This is geometric, right? So we know that x is between 1 and -1. You can even just explain that and say it's geometric with x between -1 and 1, so endpoints. You have to just, there's so many proper wordings, but the answer is no, whichever way you think about it. Now comes a derivative. So now I may gain or lose an endpoint. If I get asked that, I don't know, I haven't looked at this problem since last year, but we'll deal with part C before part D. The derivative of arctan, I would write that down. They're giving you a hint. The derivative with respect to x of arctan x. And I think it was one of the groups last week where someone was struggling and someone said, write it all out. I think it was Gabe telling somebody in his group, write the whole thing out, right? And if you do write it out, I mean, you have to with these, all right? Is an equal sign. We know, you might say, well, I know that. I know you know it. But it's going to help you generate arctan. It's polynomial expansion. Because how do we undo a derivative? Integrate. So my arctan, it's not hard, but boy, do you have to, you can't kind of be sleeping, right? People at home, wake up. All right. Why is that going to be easy to integrate, and why can't I use, I guess you could use Taylor's rule, but I don't even think you can. Why? That's geometric, correct? Don't forget you're integrating it, but it starts at 1. What's its common ratio? -x squared. I lost the stem of the problem again. That's okay. I'll go read it in just a second. Did it say how many terms or?
First 4.
Okay, first 4. So I'm good so far. So now I need to antiderivate x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7. And it did ask for a general term too? Or no? Just the first 4? Oh, sweet, I'm done. Correct? Now what's part D? That is a very, very difficult prompt. The minute I see this, I kind of puke in my mouth a little. My eraser, guys. That makes me go, uh-oh. They're asking me to find some number such that its distance between the actual value and it is less than 1 over 100. What is this a question about? It's a question about the error, right? I am in search of the actual approximation that'll cause me to be less than, I'm going to make a fake one. I'm in search of where will I be, let's make my fake one, less than 1/100th of a gap. At what number? So what do we think of when we think of error? The absolute value of the first unused term. We have to go figure out where that happens to be less than 100. So we have to go down here and write it out. Actually, I think I have it. This is a very hard question. But here is our 3/4, right? Minus 3/4 cubed over 3. Plus, why am I using 3/4? That's the location I'm hopping on the curve at, and I just ended my sentence with a preposition, but I don't want to fix it. At which I, 3/4. My kids call me the grammar police. Don't say it that way. And it actually said to use this one, so I think I'm safe in assuming that my first unused term, can someone take out a calculator? Do 3/4 to the 7th over 7 for me as a decimal. My guess is that's going to be bigger than 0.01 because it said to use the 4. Do you see what I'm saying? So go 3/4 to the 7th over 7 and tell me what we get. The one that's a great question. So remember when I said this is like 2008, but I didn't want to give you 2008 because it's coming later? When I changed this, it became necessary to use a calculator. The actual one, it's only like out 3, and it's like plugging in a half. So it's very easy to analyze the fractions. This, I should have mentioned that. Part D kind of didn't go as well as planned. But 0.0 what? 0.02-ish, so that's not it. So my first unused term, which would be 3/4 to the 9/9, that's the one that's going to be less than 1/100th. I know it. So when it asks for the number at which I will be less than 1/100th in error, it's that. This is my guess, right? The actual is arctan. The distance between them is less than 1/100. That's a super, super, super hard question, agreed? All right, here's what we're going to do.
So A is 9.
No, A is this.
Oh, what's that?
Here's my approximation at 3/4. Here's the actual value at 3/4. I'm 100% convinced that the error between, or the gap between them, is less than 1/100 because that first unused term was. That's hard, don't you think? All right. 2015 is in your note packet somewhere. I actually think it's in your work packet too. I'm going to have you start it. I don't know. I want you to try one FRQ. And then there's no homework tonight. Well, there is. What is it? 6A if you didn't do any yesterday. There's also an extra credit option, but I want you to just take on your own. Is 2015, I know it's in your note packet.
It's in the work packet.
And it's in the work packet. So Kate, well, I threw it in twice because I wasn't sure when I sent the notes if it was in there. So go try 2015. The national average was 3.9 something. Did I put that on there? The national average? Nope. I think it was 3.96. I'm gonna have you guys try. It's in the note packet and your work packet. Those of you at home, I'm gonna stop the video, but you should try the 2015, and then you should check it on your own. I'm gonna put the score rubric up for these guys.
Should have said 2050. There we go.
Yeah, you'll find it. Just keep.
I went
Oh
to the
no!
beginning.
Did my recording stop?
Yeah, I think it might.
No! When? Wait. It's paused. No, it's still recording. Click here to pause. I don't want to pause. I want to save. Oh, there we go.